Hey, welcome back to demo. This is going to be demo 2. We're talking about databases and SQL today. Jack talked about some different kinds of SQL in class. He mentioned Postgres, he mentioned MySQL, I think he mentioned Microsoft and things. We don't need anything that fancy. We're going to be using kind of bare bones SQLite. There are instructions for how to install SQLite 3 on the pre-class to-dos for today. So, just make sure you go through that and have SQLite installed because you're going to need it for the upcoming stuff. The other nice thing about SQLite is it actually stores the database locally as a file, which most SQL services don't. It's cool because then, if you create the database, you can easily tell, hey, look, I have a file created, and if you want to delete the database, you just kind of delete the file. It's easy, right? We won't be using raw SQL for most of the course, but for the next couple of weeks, we are going to be using it because it's really important to know what your code is doing under the hood. Later on, once we get into lecture 4 and stuff, we'll teach you guys how to abstract that away into just Python code using some libraries, but for now, we're sticking with raw SQL because it's cool to know what's going on, right? So that said, let's get into it. You guys remember, in SQL databases, they're made up of different tables. Let's say we're thinking of an Excel file. Excel files are made up of multiple different sheets, right? You could think of each of those sheets as a table. Let's create a table. Let's say we want to talk about movie preferences, right? We're going to need users to have those preferences, so let's create our user table. What fields do we want to have in this? Probably going to want an ID, right, like we had before. We've been using integers for IDs, so let's go for that. SQL has a specific designation for if you want to label something as like the ID of a table, and that's the primary key. That kind of lets SQL know, hey, this is what we should be referencing when we're talking between different tables and stuff like that. And also, it'll auto-populate the field for us. So for example, we've told it it's an integer, so it's going to start off by giving the first thing we put it ID 1, then 2, etc., etc. The point is, we don't have to tell it what the ID is. It'll figure it out. And we also want to say auto-increment, and that'll just prevent it from ever repeating IDs. If you don't say that, then let's say we put Jack into the database and he's number 1, right? First one. And let's say we delete Jack, but some front end has still stored the Jack's ID as 1. And then we add me to the database. Without auto-increment, because the previous ID is not there, it would restart at 1. And so then when the front end tries getting the person with ID 1, they would get me. But they were looking for Jack, so what they really should get is like some sort of 404 error that user isn't found because they were deleted, right? So auto-increment will make sure that if you keep adding people, IDs are unique across the lifetime of the database. So I would have restarted with 2 even though there was nobody else in the database. People also usually have names, so let's give it a name. But most languages call string SQL likes to call text for some reason. And then we want to specify that that's not null. By default in SQL, you can not give it some of the fields. So you have to specifically say if you want some fields to be necessary. So I'm requiring the name field when you add a user. Now for the important part, right? We were talking about movies. What's our favorite movie? The SQL uses snake case syntax. That's the underscore thing. That can also be a text not null, right? And some movies have songs in them, right? Like musical movies and stuff have songs in them. So let's say, what's your favorite song in the movie? I'm going to get rid of that just because it's long to type, but favorite song in the movie, not just in general. You can also say like car 50 or something, and that's saying also string, but of maximum 50 characters, right? This is actually converting into a character array of maximum size 50. And, since not all movies have songs like that, not all of them are musicals, this can be nullable, right? This doesn't need to be enforced. Cool. So one thing to keep in mind about the syntax I was just using, you need commas in between everything. But make sure you do not have a trailing comma. If we try creating a table that has a trailing comma, it's not going to happy, right? Sees that, and it's like, error. Near this closing bracket. And you're like, what? Where's the error? There's just a semicolon there. Except directly to the left of it is technically this comma, and that's the error. You shouldn't have trailing commas in SQL stuff. Also, SQL statements are terminated with semicolons, another thing to keep in mind, because Python isn't. Nope. Now, what if we want to insert into this table, right? Jack's discovered the service we're using, and he's decided he wants to spread to the world his love of Grease 2. Jack really likes Grease 2. I've watched it with him like twice at this point. So, insert into, right? That makes sense. We're inserting into the table. So what's the table's name? User. Then we have to say what we want to insert. So we're inserting into the name, favorite movie, and favorite song field. Remember, the ID is going to get filled in on its own. And then we have to tell it what values we want to give it, right? So let's give it, well, it's going to be Jack, right? Favorite movie is Grease 2. I think a favorite song from it is Prowling. Semicolon to terminate. Cool. What if we want to check to see that that actually got put into the database? That's what select commands are for. So we can select things from the database. So let's say we want to just select name from the database. Cool. Jack. Perfect. What if we wanted the favorite movie too? Jack and Grease 2. And if we want everything, favorite song. What if we try asking for something that isn't there? Like, favorite flavor of movie. No such column, right? It'll just throw an error. Similarly, if you try inserting into something that doesn't exist or that should be nullable, so for example, if I just try inserting into favorite flavor, again, values int, no column, right? Or if we just try inserting name, not null constraint failed, user.favoritemovie. That's because we specified this is required. Favorite song doesn't matter. That's fine. But the movie is necessary. All right. When we want to select everything from a database, saying select name, favorite movie, favorite song, favorite whatever, that takes a while to type. So, SQL has this nice select star. And that just selects everything. Okay, well now let's insert me in, right? Insert into user, name, favorite movie, values, Raahi, and I really like Lilo and Stitch. Let's go with Lilo and Stitch. Spelled insert wrong. Amazing. Insert. Lovely. So now if we try selecting all from user, cool. Now both of us are there, and this 1 and 2 are our IDs. You can also see that I don't have a favorite song listed. That's because that field is nullable. We never specified that it was required, so it's fine that I didn't stick one in there. What if we all wanted to select certain people, right? Select, then we could do select star from user. But how do we get a specific one, right? That's where where statements are for, and that's kind of like the SQL version of conditionals. So we want to select everything from a user where their ID equals 2, right? And it's generally good practice to get things by ID. We remember in the last assignment, we always had that get by ID method, right? This is the SQL version of that. This is getting everything by ID equals 2. You could also get by favorite movie. Favorite movie equals Grease 2, and that should give us Jack. Yeah. That might seem a little weak, but we can add kind of conditional logic and Boolean formulas. So we can say when ID equals 2 or name equals Raahi, right? Oh, I am the second one. What am I saying? ID equals 1 or name equals Raahi. And that'll give us both, right? Because we said either or. You can also do name equals Raahi and favorite movie equals Lilo and Stitch. So you can kind of chain these operations together. There's also not. There is an order of operations going on here. It's not first, then and, then or. You can always just feel free to look that up if you need to. It's the same order of operations as in Boolean formulas and Boolean logic. You guys are familiar with that. If not, that's totally cool. So, like I mentioned before, Jack has shown me Grease 2 twice. He is a strong proponent of this film. He's a massive fan. Let's say he's finally managed to convert me to loving Grease 2 for some reason, right? We need to update the data in the table now, right? It's out of date. It says I like Lilo and Stitch, but clearly I'm a Grease 2 fan, so let's update that. Update user. So what are we doing to the table? Well, we're setting new values, right? So we're setting my favorite movie equal to Grease 2. And Grease 2 has songs in it, so now we can maybe use the favorite song field too. So we set my favorite movie to Grease 2, and let's also set my favorite song to... I like to do it for a country. I think it's funny. Where, right? Because we still haven't specified who we're doing, right? So now we do where ID equals 2 to specify me. Cool. And now it didn't give us an error, at least, so that's a good sign. So now let's select all from user. It's updated. A couple days later, I was thinking, and I'm like, I need to erase all evidence that I ever had anything to do with Grease 2 from the world. And, you know, I'll do Jack a favor. I'll erase his evidence too. We need to delete elements from our table. So we want to delete from user where favorite movie equals 2. And as in all the other times, whenever you use where, you can always use more conditional logic. It's just staying simple for now. Right. So now if we try selecting star from user, there's nothing. We erased everything. Speaking of which, this backend doesn't really seem like it has very many users. We can probably just get rid of it. If we want to delete the table, by the way, if you want to see what tables you have right now, you just type .tables, and we see we've got the user table. If we want to get rid of the table, we just drop the table, right? Drop table. Now if we run .tables, it's gone. You can drop a table that has data in it, by the way. I deleted all the data first, but there's no necessary reason to do that. Yeah. So that's probably a good SQL primer. I recommend you guys play around in the SQLite shell yourselves, but now let's get into the code. So if you guys ever get trapped in the shell like I was a while ago, by the way, you like .exit, get out of the shell. Cool. So now for the code. Lovely. So you guys remember, we're usually working with this app.py file, and we've got all these routes telling us what to do. This time, we are interacting with an actual database, right? So let's create a different file that can house our database driver. We're using SQLite 3, so from SQLite 3, oh wait, sorry, not from, we just want to import SQLite 3. Cool. For initialization, we need to somehow connect to our database. So, self.con, let's call this connection variable equal to SQLite3.connect. And remember, SQLite 3 stores things in files. So let's give it the name of whatever database we want. I'll call this todo.db because we're still working on the task manager from last week. And then we want to also say check same thread equals false. And that's kind of important. This is just saying, hey, multi-threaded applications can use this. The reason you need to specify that is because usually if you have more than one thread interacting with a database, that can cause conflicts if they both try mutating or reading at the same time, right? Our programs are not going to get complicated enough for that to happen, so we don't really have to worry about that. Just know that you should have that in there. And then we're also going to somehow need to create our table, right? So let's use my favorite programming tool and write a function for it later. Later being now, I guess, because I see we've gotten there. Next one. Cool. So now what do we do? Well, we need to somehow execute that command I showed you earlier, right, for the create table command. Well, conveniently, we just use our connection to the table to execute that command. Commands in this format are actually executed as strings. So we pass in a string of SQL code to execute the SQLite 3 command into the Python. Let's give it a multi-line function, a multi-line string, sorry. At this point, by the way, I would highly recommend you go over to your extensions and get this highlight string code extension. The reason for that, I'll show you. Let's disable it for now so you guys see. I'll start typing, right? That should be there. That can be there. I just like things looking pretty that way. We try typing create table. Okay, Kite's being nice and auto-completing for me because I have a cool IntelliSense extension, but this doesn't like look particularly useful for us, right? We don't know if we typed these commands correctly or not. We enable highlight string code. Voila, now there's syntax highlighting. And if you'll notice, it's also being kind of gross about, hey, it's saying the multi-line string goes down here, right? Because at least for me, green's my string color. That's it reminding you, hey, SQL commands end with a semicolon. And then the syntax highlighting is fixed. But anyways, create table, we're doing our task manager, create table task, right? What should go in this? I mean, like before, we're going to want our ID integer, primary key, auto increment. That's cool. We're going to want a description, and that can be a text. We're going to enforce that. And then we're going to want done. Now, done is a Boolean, right? So maybe you're thinking, okay, let's just type Boolean. Hey, it's syntax highlighted, great. The issue here is different flavors of SQL have different data types we're allowed to use. SQLite is a very bare bones version of SQL. It doesn't have the Boolean data type. So instead, what we're going to do is actually store things as integers, where 0 is false and 1 is true. And that should also be not null. Remember, do not put a comma here. But we do need a semicolon there. Okay. And then let's commit that. What committing does is essentially like hitting Control S, right? Think back to the Excel file analogy. You've created your sheet, but now you need to save the fact that you've made this file, right? Even if you just want to call it untitled. In our case, we actually named the file task, or we named the sheet task, right? The file is the database. In fact, I'm going to wrap that in a try except block. And the reason is just in case something happens to go wrong when we're creating the table, we want to print out a nice Python error. This is just going to throw some wacky SQL error that is going to be gross and hard to look at. This will probably also be gross and hard to look at, but at least slightly less so. Cool. Now for deleting the task table. Again, when we're executing SQL commands, we type .execute on our connection to the database. It's going to be a multi-line string. And if y'all remember, the code to drop a table is drop table, right? Drop table, I can't spell, table, task. Well, now we're running into the issue is, what if we try calling this function before we even made the table? It will just throw an error if you try doing that. So instead what we want to do is drop table if exists. And that'll say, hey, if task isn't a thing, just don't worry about it. Only delete it if it's already there. Cool. And we need to commit that, right? Because if we're deleting a sheet, we should probably save that in our Excel file. I'm using Excel files as an analogy. There is also a strong reason we don't actually use Excel files as databases. They're not optimized for this kind of thing. It's just a good kind of way to think about it. So get all tasks. Hopefully you guys remember, boxes in the database. We're going to be highlighting over a bunch of them and returning all of those. So cursor equals self.con.execute. And this time we're going to execute the select command, right? Select star from task. This is going to give us something kind of wacky looking. Because it's going to give us a SQLite 3 object, but we would really rather have a list. So let's make our tasks list. And this cursor is also kind of like a multi-dimensional array, a two-dimensional array, right? Because we highlighted over everything in our database and copy-pasted. So that's going to be a lot of rows that we went over. Luckily, the object is iterable, so we can just say for row in cursor. That'll give us each row. We can kind of treat that like an array now. We want to append to our tasks ID. Okay, well, our ID is in the row somehow, but what is it? Just the first element. it's going to be in the same order as when we created the table. So ID will be the first element, or 0. Description will be the second element, or number 1. And done will be the third, or number 2. So, description, row 1. Done, row 2. But remember, done is a Boolean. We're just kind of pretending it's an integer for the sake of the database not having Booleans. So let's just cast that back into a Boolean when we return it to the user. Right? Makes sense. And then we just return tasks. Return tasks. Lovely. Now, this is convenient because even if it doesn't find anything in the database, it'll just return an empty list, which is what we want. Inserting. That's not bad, right? We know the insert command is just insert into. Also, keep in mind, all of these functions need to have necessary stuff as per. So, for example, we need description and done. Know what to insert. So let's get our cursor again. And this time, even just call it the cursor. There's a reason we need the specific cursor, and I'll explain that in a hot second. But for now, let's just execute a command. By the way, when we're doing self.con.execute, what that's really doing is grabbing the cursor and then running .execute on that. It's just kind of a nice shorthand for it. We'll keep doing that on X. Really rather it look like. So we want to insert into task, specifically description and done, value. But now we've got a problem, right? Because remember, our syntax highlighting is being kind of nice, but if we turn that off really quickly, this is just a string. We can't just type the word description. It's not going to know what's going on. Well, SQLite 3 has taken care of this for us. It says, hey, just put question marks here, and then give me the values you want as another parameter. So parameters equals description and done. And you don't actually need this parameters equals. You can delete that. This is a tuple. So it's a tuple matching the values. And so for each value, you need one element. And it has to match the order of the question marks too. So description is the first question mark, done is the second. Cool. And then we have to it. And I'll semicolon there. Cool. Now that that's been committed. Also, if you're wondering what we're committing and what we're not, we commit things when we would save them. If we're just reading from the database, there's no need to commit anything because we haven't updated any information. But if we're inserting into it, then yeah, we should probably be committing that. Then what do we want to return? Well, returning the ID of the task we just created is probably a sensible thing to do. It's one of the options. Let's return that. So return cursor.lastRowID. So this is why I wanted to grab the cursor, because using the cursor, you can actually have it point to the last row ID and grab that for you. Why the last row ID? Well, we just inserted into the database, right? So the task we just created is going to be the very last task. So if we get its ID, we'll be returning the ID of the task we just created. Get task by ID. Y'all remember the select stuff. That's also not bad, right? So cursor equals self.con.execute to execute the command. Select star from task. This time it's a where ID equals. We're going to do the question mark thing again. Oop. See, the green stuff is reminding me I forgot the semicolon. And so this time we need to give it ID. But, and this is a mistake that I've seen a lot of people make, and I honestly make it. When I said I've seen a lot of people, this still has to be a tuple. It's kind of strange to look at because it feels like we're just giving it one thing. What's the need to do this gross looking thing? But the Python function is going to be expecting a tuple. So even if we're only going to be giving it one value, you have to wrap that in parentheses and make sure that the comma is there. That just marks it as a cool. We've got our cursor. And now what? We can't just return the cursor because again, it's a SQLite object. But also keep in mind, this cursor could technically be more than one row. It's true that we've specified the ID and IDs should be unique, but we could have just as easily specified whether the task was done or not, and then we would have gotten a ton. So for all this knows, it has more than one row that it's gotten out. We happen to know that there should only be one, so we can just say for row in cursor, and this loop should only happen once. Return ID row 0, same stuff as before. Description, I can spell row 1, and then done is like last time, bool of row 2. Cool. We do still have kind of an issue where what if we try getting an ID that doesn't exist? Then we don't really want to return anything, right? But this for loop won't go through if there's nothing in cursor. So just outside the for loop, we can just say return none. Now updating task by ID. Well, again, we're just going to be self.con.executing. There's a common trend in a lot of these commands. They tend to be self.con.executed. And this time we want to update task. Remember, we're going to be setting the value. So we want to set description and done to the values question mark, specifically by ID. So where ID equals. And this is why I mentioned order before. Because even though we're passing in ID first, because it's the last question mark, we have to give it as the last item in the tuple. So description, done, ID is how we would do that. We don't really need to return anything in the line, although we do need to omit. Did I forget to commit anywhere else? No. And now for deleting the task by ID. Similar stuff as before, right? Let's just self.con.execute, this time the delete command. So we want to delete from task where ID equals comma and then ID. Remember, this is still a tuple even though we're only giving it one thing. So that's pretty much the database section done. You might be curious about what this last line is. Database driver equals singleton database driver. Let's scroll up a bit. Sorry if that makes you dizzy. Here is where we've defined the singleton function. You don't need to fully understand what's going on here, but the idea is the singleton function takes in a class and returns something that would, when called, give you one and only one instance of the class. The reason we want that is because we don't want to have multiple weird connections to our database running around at the same time, right? We just want the one connection so that we don't mess anything up in trying to interact with it. So that's all that's going on there. Cool, so let's save that. And now we can go back to app.py and try to start playing with things. So we're going to need to import a few things now. We want to import request, just because we need to get the request data. But let's also import db. Now what's db? db is the file we just wrote. This is actually called db.py. So we're importing that so we have access to it. And now that we've imported it, we can just db equals db.database driver. And this will give us a singular instance of our database. Exactly what we want. Just for our convenience, let's also define a success response and a failure response. Because if you guys noticed, there's a lot of code that goes into these that's repeated over and over again. It's kind of a pain. So let's just abstract that away into a function, right? Favorite thing to do. We want to return json.dumps. Sure you guys remember that from last week in the assignment. Success true, because this is the success response. And data, this should be wrapped in quotes, with the status code of whatever code we pass in. If you're curious about this equals syntax, that just gives it a default value. So you could pass in a value, or if you don't pass in a value, it'll default to 200, which is generally what we're going to be wanting. Let's default this to 404 actually, because most of our errors today are going to be not found. In this case, we'll return json.dumps, success Ooh, two S's. False, because this is our failure response. And then instead of data, we'll return what the error message was. All right, I did. That's exciting. Run the code again. Cool. Now we've gotten that out of the way. How are we going to get the tasks? Well, this is super easy now. We've already written the function for this, right? We just have to return a success response of db.getAllTasks, right? We already did this. In fact, let's just double check to see if that's working. So, that's not the way you want to go to. So if I go to here, I think you guys can see my terminal window now. Then all that I have to do is python3 app.py. Cool, and now let's go into Postman. You guys can see it. Get tasks. Success true, data nothing, right? Makes sense. We don't have much going on in the database. Let's create a task. Well, we know what to do here, right? First, we have to get the information from the body. So body equals json.loads request.data. Then we get the description, which is all that they really need to create the task. So description equals body.get description. And we only want to really create the task if they gave us the right information. So if description is not none, db.insert task table description. That's all that takes in, right? Cool. And then we want to return. Oh, we want to get the ID, right? Because we specifically did this, that it would return the ID of the task we created. We want to return a success response db.getTaskById task ID. I can spell. If they didn't give us a description, then we'll just return them a failure response with the message being no description. And let's have a 400 for bad request, because I defaulted to 404, which is not found. Cool. While we're at it, let's just do get task really quickly. Passing in the task ID, this time it'll just be return success response db.getTaskById task ID. Or will it? What if the task ID doesn't exist, right? What do we do in this case? We told this to return none, right? So let's say task equals this, and then if task is not none, then we'll return a success response with the task as the data. Otherwise, we'll return a failure response with error task not found. And that's a 404 error, so there's no need to update the code. Okay, let's just check if that's working. Cool. Well, that's fine. Now let's try getting a specific task, right? We don't have anything, so this should throw us an error. It says false error, task not found. Nice. Okay, now let's try creating a task. What should my description be? We'll have a networks prelim tonight, so let's say that. Error, insert task table required one positional argument. Done. Ah, see? We forgot to tell it what was done. So, let's go back here. Where is it? Here. We want to initialize done to false. Right, because when someone's putting a task on their to-do list, it'll probably start off false. Now that we've fixed that, let's try it again. There we go. And this time it gave us the result we wanted, right? Which is the task. So now if we try getting tasks 1, which is the ID we just created. Perfect, we got the task. Back to the code. If we want to update a task, well, we can either update the description or update whether it's done or not. So let's try getting those from the body. JSON.loads request.data description equals body.get description, then done equals body.get done. There are a couple of different things that could happen here, right? One is if neither of them were supplied, in which case they didn't give us enough information, right? So if description is none and done is none, then what we want to do is return a failure response. Not enough information. 400. What if just the description is none? Then we can return a success response, right? But we have to update the value first. So db.update task by ID. Task ID is the ID. The description is going to be task description, right? We want to keep that the same. Where can we get that from? Oh, we wrote a function to get it, right? Let's just add another variable here. Task equals db.get task by ID, task ID. Then we can just say task, grab the description. And then done, because we know that done can't be none, because if they were both none, it would have gone here. If done is none, right? Because it could be the case that done is none and description isn't. In that case, we want to update the task by ID for the description, but leave done the same. And then the final case is if they're both valid and they wanted to change both values, and that's fine. Then you just do else db.update task by ID, task ID, description, done. Cool. Now we want to return a success response with the task that they've updated. We can just say return success response db.get task by ID, task ID. Cool. And finally, let's just do delete task to get all of that out of the way. Body. Oh, wait, no, we just need the task ID for that one, don't we? Cool. So in that case, we'll just say, hey, db.delete task by ID, task ID, right? But remember in our DB file what we did if we deleted the task by ID and that task didn't exist. Nothing. What do you think happens if you run the SQL command and you say delete from task where ID equals 3? Well, the database would just stay unchanged, right? That's totally fine. But if they try getting you to delete a task that doesn't exist, there's still probably some wacky stuff going on, and you want to let them know that the operation wasn't completed because it couldn't be. So first, let's say task equals db.get task by ID, task ID. And then we're returning none otherwise. So if task is none, return return failure response, task not found. Otherwise, we know the task is there. So then we just have to run db.delete task by ID, task ID. And then we can return a success response with the task. That might seem kind of weird to do, right? They just deleted the task, why would they want it back? But it's a good confirmation that they deleted the right thing, right? All right, so now let's play with this in Postman. Back to Postman. Cool. Let's get all tasks, as in the one task we have. Good. Also, if you noticed, I was saving the code in between those instances, and the server was actually restarted. Because we're using a database now, the data is persisting even though the server is restarting. That's part of the reason this is great. Cool. So let's say that I want to update this. I want to update the task with ID 1. Networks prelim maybe tonight. I really haven't gotten much done. I want to feel good about myself about something I am getting done. Let's say record demo. Right? Because that's what I'm doing right now. Send that. Operational error. Okay, that looks like a SQLite error. Lovely. Let's figure out what's going on there. So this is an update task, and it's calling db update task by ID. Ah, this isn't how we do update syntax. Update syntax should be description equal to question mark, and then done equal to question mark, right? The syntax I'd used before was actually the insert into syntax. That's my bad. All right, that should be fixed now. So if I try sending this request again, cool. Now it looks updated. So if we try getting all the tasks again, JSON, the description has been updated. Perfect. Well, the demo's almost done. So let's just say that it's done. Let's just mark that as true. JSON says that version, type, send. Cool. What happens if I try updating it with no information? Should throw an error. There we go, error, not enough information, just like we want. Well, okay, the demo's pretty much over by this point. Let's just delete the task, right? So, at that point, what we have to do is change this to a delete method and send that over. And it returns the correct information of everything we wanted to delete. Now when we get all tasks, they're gone. Perfect. All right. So, that was today's demo. I hope you guys followed along. Feel free to post in the Slack any questions you guys had, stuff like that. But yeah, that'll be all for today. Thank you guys so much, and good luck on the assignment.